Dear conference team, dear respected experts and scholars, the title of this paper is Computer Vision-Based Method for Identifying Grouting Defects of Prefabricated Building Sleeves. Abstract. In order to accurately detect the grouting defects of construction sleeves, a method for identifying the grouting defects of prefabricated construction sleeves based on computer vision is proposed. The 3D target detection algorithm is used for feature point detection, and the corner detection model of assembled building is constructed to obtain the feature angle detection results and match the feature angles. The constraint relationship is extracts from the data in the image screens of grouting defects of the prefabricated construction sleeves, and the parameters of the film defects of the construction sleeve are calibrated. Finally, the defect identification is completely through the sleeve grouting scanning of computer vision. The experimental results show that the method based on computer vision to identify the grouting defects of prefabricated construction sleeve has strong recognition ability and can well complete the defect identification. Keywords: computer vision, fabricated building, construction sleeves, sleeve grouting, identification of grouting defects. 1. Introduction. The modernization of the construction industry is the development trend of future construction industry, and it is fundamental change of construction production mode from extensive production to intensive production. Compared with traditional cast-in-place building model, which has large environmental pollution and long production cycle, the prefabricated component model of prefabricated building has the advantage of fast construction speed, reliable quality, energy saving, and environmental protection, and labor saving. The key of prefabricated structure is how to ensure the connection performance between prefabricated components and the overall performance of the structure. The quality of this performance is closely related to the connection between prefabricated building components. The working performance and durability of the node connection will directly affect the reliability of connection and the safety of the overall structure. At present, the most commonly used connection method for the main reinforcement of prefabricated components is prefabricated concrete structures is the reinforcement sleeve grouting connecting. That is, the connection reinforcement is inserted into the metal sleeve, and then the higher strength grouting material is poured. The stress is transferred through the bonding of grouting material and sleeve wall, and the bonding of grouting material and reinforcement. 2. Feature recognition of grounding defects in prefabricated building sleeves based on computer vision. 2.1 Feature point detection. There are a large number of key feature points in the prefabricated building that need to be displayed externally, but the distribution position of the key feature points cannot be directly displayed through the 3D model, and each key feature point in the prefabricated building needs to be detected before display. The 3D target detection algorithm of computer vision can detect and identify key feature points in a targeted depth, especially for the key feature points that are deeply hidden inside the prefabricated buildings. The 3D targeted detection algorithm can even track the key feature points in real time. 2.2 Feature corner detection and action. Detect the characteristic corners of prefabricated buildings. Take the circular template as the object template and take the center of template as a curve. The corner detection model of the prefabricated building is shown in figure below. Two point three. Prefabricated building algorithm feature corner action and matching. The parallel movements of the template in the image range. The pixel change of the photosensitive area and the change of brightness can be calculated and expressed by the following formula. Three, recognition of grounding defects in prefabricated building sleeve based on computer vision. 3.1 Calibration of grounding defects and of prefabricated building sleeves. Calibrate the grounding defects of prefabricated building sleeves based on computer vision. In an auto situation, the conventional prefabricated building sleeve grounding defects use a standard reference to constrain the image of prefabricated building sleeve grounding defects, so as to determine the parameters of the prefabricated building sleeve grounding defect model. 3.2 3-light beam laser stereo vision scanning based on computer vision. The 3-band laser stereo vision scanning method based on computer vision used in this paper is mainly composed to multiple 3-band laser stereo vision scenarios. The angle division method is used to capture and calculate the animation data in 3-dimensional space. At the same time, the 3-dimensional scanning sampled image is also used to carry out three-dimensional point seizing on the quantum defect image of prefabricated contraction sleeve. Four, data processing of quantum defects in 3D prefabricated building sleeves. Data capture of quantum defects in prefabricated building sleeves is one of the important way to synthesize human motion animation under normal circumstances. The original data captured by motion capture equipment will be scattered due to noise and other environmental factors. Due to the lack of the data and other factors, this paper mainly focuses on post-processing and the collection of the quantum defect data of the 3D scatters assembled building sleeves obtained by the motion capture device. Five, identification of quantum defects. There are three main steps to apply computer vision to image mosaic in computer system. The precise homography metric algorithm is needed as an operation basis in computer system program. In the process of image transformation and mosaic, it is necessary to estimate the linear motion change of feature points. The process of image mosaic and transformation can be expressed as six. Experimental studies. In order to verify the effectiveness of the method proposed in this paper for identifying the quantum defects of prefabricated building sleeves based on computer vision. Comparative experiments are designed to compare the method proposed in this paper for identifying the quantum defects of prefabricated building sleeve with the traditional method for identifying the quantum defects of prefabricated building sleeves based on SURF, and the method for identifying the quantum defects of prefabricated building sleeves based on edge fashion. The model effect is analyzed by comparing the results. The experimental image sample is shown in the figure below. Seven, conclusion. In order to improve the construction quality of prefabricated buildings, a method for identifying sleeve quantum defects in prefabricated buildings based on computer vision is proposed, and its performance is verified from both theoretical and experimental aspects. It has high defect identification accuracy when identifying sleeve quantum defects, especially compared with the SURF-based recognition method and the edge function-based recognition method. The defect recognition accuracy of this method is significantly improved, and the recognition accuracy accuracy of this method is 99.62%. Therefore, it shows that the proposed defect identification method based on computer vision can better meet the requirements of grading defect identification for prefabricated construction sleeve. In the future research work, the efficiency of defect identification will be further tested and studied to improve the practical application reliability of the detector identification method. Okay, that's all. Thank you. Thank you.